So welcome. A few words about Wix. Who doesn't know Wix? Okay. So Wix is a very large Israeli company which you've all heard about. Currently we have about 1,500 employees. We have just passed 100 million users. Yay! Last week. Thank you. We have about 400 developers. So actually more, I think, almost 500. We have engineering offices here in Tel Aviv, in Beersheba, in Vilnius, which is Lithuania, Kiev, Ukraine, and Dnipropetrovsk, which is also Ukraine. Also, we have global offices in the US and other places. So yeah, we're pretty big so far. I think one of the largest Israeli high-tech companies, if not the biggest, not sure exactly. In terms of market value, last I checked the stock, I think we're probably more than $2.5 billion. So yeah, way for us. Hopefully the stock will continue growing. So we're not exactly Facebook scale, but we're very, very big. And of course, with the size comes a lot of complexity. We have a lot of interesting problems if anybody wants to work on them. Just saying. So yeah, anyway. So today is a meetup that is all dedicated to operations and how you deal with failures and how you learn from failures. I'm going to be talking about how to deal with failures, and Nathan is going to talk about how to learn from failures, how to do postmortems, and how to learn from the problems that you had. So the first talk is when the shit hits the fan, WebOps Disaster Survival Guide. So you know that today, in today's world, we're no longer building desktop software. We are actually building online services, which means that when there's a problem, we have to wake up and fix it now. Like, we don't open bugs anymore with vendors and have to wait for 2 weeks to, just to get a call from someone and to actually reproduce the issue on our office and be completely decoupled from the client. No, these days, we detect problems very, very fast. An incident would have impact on millions and millions of users. And just to give you an idea of what we're talking about, if you're talking about Wix scale or Facebook scale or something like that, maybe we have 0.1% error rate. But if you're talking about 100 million clients, how many clients are suffering from 0.1% errors? Sorry?
100,000.
Exactly. That's a lot of people in pain. So we have to deal with a lot of issues seriously, and we can't just defer them. So you'll have seen this, you'll know this. You've all been to companies where someone tells you something like, okay, this system is never going to fail. It has never failed yet. The vendor says that the uptime of this system, the mean time it will fail is gazillion years. Yes?
Can I quote you?
Yes, you can quote me.
Uptime is an illusion caused by lack of monitoring.
Yeah, I was probably drunk when I said that, but it's true. Anyway.
Is that a good thing or a bad thing?
That depends how drunk you are. You're still on your first beer, I think, no? Yes? First beer, second beer?
First beer I had while I wasn't riding a bike.
Oh, okay. Cool. So first one. Anyway. Yeah. Guys. So anyway, we've all been in those situations where people tell you something like this, and we all know it's bullshit, right? Because all systems break eventually. It doesn't matter how reliable we think they are, or the vendor tells us that they are, highly reliable, or whatever. Everything breaks eventually. This is true for nuclear reactors. Everybody remembers Chernobyl, unfortunately, and Fukushima. This is, of course, very real for our systems as well. And how do people feel when a system breaks? How do people react when a system breaks?
Panic.
Yes. They panic. This is the normal reaction everyone has. But what kind of a reaction, what kind of emotional reaction do we want to have? How do I feel when the system breaks? Yes, I am.
You're justifying your paycheck.
That is true, but no. What I'm actually feeling is I'm feeling greedy. I'm feeling really, really greedy. This is how we should be feeling. Because, although downtime is really, really bad, and data loss is bad, and all the consequences of failure are bad, an incident is also, a failure is an opportunity. And it's a really, really big opportunity, and it's an opportunity that is also very rare. It's not, incidents are rare, because we want them to be rare, because of the impact. But it also means that we don't have a lot of opportunities like a failure. What do I mean by that? So when you have a failure, your system is in condition, it's in a state that you never planned for. It's something that you never thought was possible. You never planned for this, you never imagined this could happen. So it means that you can learn a lot from this. Okay? If I haven't planned for something to happen and it did happen, something that I thought was impossible, this is a gold mine. Okay? It has proved all my assumptions to be wrong. And the data that I can get from an incident is priceless. Priceless.
Unless you were covering up beforehand.
Of course. And the point is that it's a big opportunity to learn and to make our systems better. And this is what we should be thinking about when we have an incident. How do we basically profit on that incident? How do we monetize on that incident? And also something that people don't take into account, that once you have an incident, suddenly you're allowed to do a lot of stuff that you weren't allowed to do before. So it's an opportunity to do stuff that maybe you would never get an approval to do otherwise, or maybe you were too afraid to do, or maybe regulations said that you couldn't do them, but suddenly you can. So an incident is also an opportunity for change, because a change has already happened. This is a reality. Unfortunately, a lot of people don't get this. And when there's an incident and everyone is panicking, your manager will probably tell you something more like this. Cut the bullshit, get the system up and running right now. I don't care about this being an opportunity for learning. I don't care about this being an opportunity to do stuff that we can do before. I just want the system up. And what normally people do when they have this kind of approach is they say something like, let's call Rambo Ops. Every company has one. Every company has some guy that they call that's supposed to magically fix everything. And that guy probably knows everything about everything, and he's like a mega engineer or whatever. And he can fix everything, and when there's an incident, your manager will tell you, go call Larry, or whatever his name is.
Shraga.
What, sorry?
Shraga.
Shraga, yes. Sorry?
Maybe a girl.
Maybe a girl, I don't know, Michelle. Let's call Michelle, go call Michelle, and Michelle will fix everything. Does this work? No, it doesn't.
Folks, it doesn't scale.
It doesn't scale, first of all. So first of all, Rambo Ops approach doesn't scale. And second, it won't work all the time, because eventually Michelle is going to quit the company. Maybe they called her too many times during the night, and she has a life, Maybe Michelle is on vacation, finally. What, sorry?
What if she's Shomer Shabbat?
What if she's Shomer Shabbat? Yes, that's weird. Anyway, but that's not the only case. The real problem with this approach is that no single human can deal with complex systems. Michelle is not a Superman, okay? Eventually,
Now you can switch back to a man.
she's not a Superwoman either. She's not Wonder Woman or whatever. It's not the point. The point is, when systems grow more complicated, when they grow more complex, eventually they reach to a situation, to a state, where the system is so complicated that no single person can understand them and handle them on their own. Plus, when you have an issue and you need to debug a system, you need to have tools in place for debugging. You need to have interfaces for debugging. You have to have monitoring systems. You have to have log pipelines, and so on. And this all has to be implemented up front. So it doesn't matter how good Michelle is as an ops engineer or as a developer or whatever, if no one is bothered to implement all that stuff beforehand, there's really nothing she can do. Okay? Think about backups, for example. If your database is broken and you don't have backups, and you didn't take care of backups before the incident, how can Michelle recover the data? That's gone. Okay? So this doesn't work. What you need to remember is that reliability is a long-term effort. We cannot achieve high reliability and we cannot build reliable systems if we are only reactive, if you only try to fix stuff when they break. The only way to achieve reliability is to work towards reliability in the long term when the system is not failing. Okay? And this is very, very hard because most times and most managers would not emphasize and would not budget for reliability when everything is working properly. And this is one of the ironies of reliability. Reliability only becomes a priority when you don't have it, or when you understand that you don't have it, which means that the system is already broken. That's life, I guess. Another thing that is really, really important to understand, which is another irony of reliability, is that reliability comes from real-world experience. And how do you gain that experience? Failure, exactly. In order to obtain reliability, you have to have an unreliable system. So another irony of reliability, which I think is nice anyway. Okay, so now that we understand that reliability is a long-term effort, how do we get there? Basically, 3 not so easy steps. We need to prepare ourselves, we need to handle disasters when they occur, and we need to learn and improve from those disasters. And Nathan is going to elaborate more on that. So, first thing when we're talking about preparing for incidents, realism. Be realistic about your system and about your expectations. So, business requirements are a very good example of this. Many times I go to a company and people told me some business requirement that they had for the system. Something like, we want 100% uptime. Okay. We all know that's not possible, right? So you tell them, okay, so it's not possible, you can't have 100% uptime. They're like, why not? And then you explain it, blah, 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 and they say, okay, so I want to have 5 nines. Okay? Sometimes you get a company and they say, yes, we have 5 nines reliability. We do. And it's like, do you actually know how much is 5 nines? Of course we do. How much is it? It's like, I don't know, maybe an hour and a year? Like, no, it's not. How much is it?
4 nines is 52 minutes
a year. How much is 5 nines? About 5 minutes a year. About 5 minutes a year. Okay, so let's do a quick computation. If we're talking about 4 nines, we're talking about 5 minutes a month. So let's, yeah. So how long does it take you to get an alert, wake up, get your laptop, type in the password, and look at the alert? You haven't even done anything, and let's say that you were awake to begin with. How long did that take?
Did I wake up next to my computer? Yes, you did. Okay, so a normal day. 37 seconds.
Is it naked? Yes. How long does it take for you? How long does it take for the monitoring system to detect a problem and alert you on that?
1,000th of that?
No.
Are they texting me? Like, what do I have?
So you have windows, you have detection windows, you have buffers in PagerDuty and whatever. It takes you about a few minutes to get
You don't
to
monitor the system every second.
No. You wish. So even the best algorithm for detecting anomalies, for example, needs at least 3 data points to detect an anomaly. At least 3 data points. And most systems use a 1-minute resolution for the data collection. So we're talking about at least 3 minutes. Okay? In real life, we're talking about more between 5 and 10 minutes just to detect an alert on the issue.
Unless the user has my phone number.
Yes. Which means we have already gone way, way, way beyond 4 nines or 5 nines or whatever bullshit number that you've heard. it's really, really hard to actually provide those kinds of reliability goals. And what, sorry?
When Feynman investigated the Challenger disaster, they had 1 in 10,000, 1 in 100,000, which is 5 nines, right? And he said the same thing, is that they've made up the numbers so that they can claim to accomplish whatever they wanted with their salary, but they have not really investigated this properly.
Yeah. So you would hear a lot of bullshit numbers. Now the problem with bullshit numbers, other than the fact that they are annoying for engineers to hear, is that they actually drive design. What happens when you try to design a system that's supposed to be 5 nines reliable? You will build a very, very complicated system. And the problem with complicated systems that is A, that they are very expensive, and B, they are very, very hard to build and debug. Now, I don't know about you. When I'm building a system, I want the system to be simple, because simple systems are easier to understand and easier to fix. So by relaxing the business requirements, we're actually helping ourselves to get better reliability in a system that we can actually handle. So this is very, very important. And many times when you start asking those questions, and you force the business people and yourself to prove your assumptions and definitions, and assumptions that you've made, for example, about the clients. Are the clients willing to accept X amount of downtime? Often you would be very, very surprised by the answer to this. I'll give an example.
They also say 5 nines.
No, they won't. They won't.
ISP doesn't give them 5 nines.
Yeah. So I'll give you an example. Everyone says that in finance, everything has to be consistent. What about checks? Is a check consistent?
Hopefully.
No, it's not. It's very, 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 very not consistent.
Be annihilated.
Yes.
They should be purged.
But in Israel, a lot of people pay with checks, and everyone is fine with 1 day delay until you know if the check is bounced.
That's why we're Israel.
Yeah. So suddenly, when you're using an electronic system, everyone's like, no, we can't have 2 milliseconds delay. That's horrible. That's BS. Obviously, the clients are willing to accept 1 day delay. So,
Not on Wall Street.
what, sorry? Not on Wall Street, no. But not all financial systems work on Wall Street. So,
Yeah, my landlord has a guy deliver the receipt. It takes him 4 weeks.
yeah. And that's my point. So you actually have to prove your assumptions about the business requirements and all of that. And we want to simplify the system because simple systems are easier to maintain, to debug, to understand, and so on. Very, very important. Basically, be honest with yourself. Second thing we want to do is practice and plan. Again, the only way to obtain reliability is to actually have an experience with reliability. What do you do when you don't have enough failures? I know it sounds ridiculous. Yeah, you could generate failures, but you could also practice. And why is it so important to practice? First of all, because often you would not know what kind of skills and what kind of tools you need. Okay? Often you go to someone and you're like, so when there's an issue, maybe you need to take a thread dump from production. We use Java, okay? So maybe you need to take a thread dump from your JVM. And often people would discover, and sometimes during an incident, that they don't have permissions to obtain a thread dump. That's a problem. Why don't they know up front if they have permissions to take a thread dump? They've never tried it. They've never practiced. They've never trained on that. Same goes for your monitoring system. Okay, you've got a lot of metrics. How many of them are actually meaningful? How many of them actually show you what they think they show? Which metrics are important?
Yes. Regarding permissions, I found that managers have some kind of concept that permissions are a reward. Because they have a cigar, they're going to go far, yada yada, they're never going to die, they're going to make it if they try. Everyone's going to love them. Is there my response to them is, you're only getting in people's way. And usually I can force my will on them. Is there something... Sorry? Well, of course, but is there some industry way of saying that, some nice way of telling managers that permissions, some real human needs permissions to fix things?
This is one of the ways. Because if you actually practice your disasters, then you would actually show them, okay, listen, I can't fix this unless I have permissions for this. You show them a real-world use case where you actually need those permissions. And this is another reason why it's critical to actually exercise. Also, improve real use skills. So I'll give an example. How often do you recover a database? Once a year? Once in 2 years? What, sorry? Once a quarter, hopefully.
Because there is a big company that
Yeah.
tells us to do it.
How often do you recover a data center? A data center? No, probably not.
No, a system that actually simply works.
Probably once every few years. How often do you recover your DNS records and SSL certificates? And I'm not talking about renewals. Oh, you know what? Even renewals. Most of the certificates are issued for 2 years. So how often do you issue a certificate?
How often does GoDaddy
Every 2 weeks.
Yeah, exactly. Every 2 years. With Let's Encrypt every 3 weeks also. But with other providers, we're talking about years. So what are the chances that you're going to remember exactly how to do this during an emergency with all the pressure?
0.
Almost 0, yes. Which is why it's very, very important. Which is why it's very important to exercise those rarely used skills. Otherwise, chances are you probably won't be able to do this when you actually need to do this during an emergency. Another very important thing is decision lines. So do you know what the decision lines are? Okay.
No.
So you know how it's when you're doing something, maybe you're programming or writing a script or whatever, and it's like, when are you going to be done? About 5 minutes. And then 10 minutes later, somebody asks you, when are you going to be done? About 5 minutes. 2 hours later, when are you going to be done? About 5 minutes later.
You should run for government.
Yes, exactly. The government is expert in that. When are we going to finish the train to Jerusalem? 2006. When are you going to finish the train to Jerusalem? Yes, in a year. Yeah, exactly. So it's been a year since 2006. Yeah. Anyway, not the point. The government is shitty. All governments are shitty.
Don't vote for them.
I never do. So the point is, you need to have a decision line. You need to think up front about time boxing every operation that you do during an emergency. Okay? Maybe you have a recovery plan, but you're going to wait so long before you activate that recovery plan because you're going to be up 5 minutes from now. So you time box your recovery efforts up front, and you say, okay, if I'm not done recovering this data center in about an hour, I'm going to start failing over to a different data center. If I'm not done fixing this issue debugging this issue in an hour, then I'm going to recover from database, restore from a database and suffer data loss. But you have to time box up front. Yeah, sorry?
Drop dead timeline for fixing.
Exactly. For almost everything that you do. But in order to actually have those decision lines, you have to measure in advance how much time operations take. For example, if you want to exercise a decision line about failing over to a different data center, you have to know up front how long it takes for the failover to complete. Okay? So again, it depends on actually exercising those earlier skills and all of that.
Do you have your own data centers, or do you use
At Wix? So currently we have a colo in one data center, and we have a few other locations. We're actually transitioning to work on Amazon. So very, very soon, what, sorry? No. Very, very soon, Wix will be 100% cloud-based, but that's in the future. Anyway, not the point.
100% really?
Yes.
Where's the long tail?
Yeah, how many nines?
How many nines?
cloud? There's always some computer somewhere.
Yes, some amount of your data is always being transferred by a thumb drive.
Anyway, error budgets. Do you know what error budgets are? Okay, so error budgets is a concept that was popularized by Google. And basically what it means is that you have a preset, let's say, amount of errors or downtime that you're willing to accept. Usually it depends on an SLA that maybe you have a contract for, or maybe that you've set for yourself, what is known as an SLO. which is service level objective, or service level agreement, which is SLA. And let's say that you're talking about 3 nines. Okay? What happens if you, by the end of the month, you find out that, your system has been up for 100% of the time? That's great, right?
Time to do
Sorry?
to take it down.
Yes, it's time to take it down. Because you have agreed to provide 99.9 reliability, you actually have 0.1% of the time that you can use for practicing and for generating errors and faults, or for doing risky stuff. So this is an error budget. It's basically a budget that if you haven't gone over the budget, then you can spend it. And what can you spend it on? You can spend it on improving your reliability.
You shouldn't be doing when you're practicing failure states, you don't do this in parallel with your 100% system?
You do. But for every risky operation, so not all practices are, not every practice operation is risky. Okay? Recovering a database is probably not risky. You can do it on the side and so on. Some practices are risky.
Fisting a live VC2.
For example, okay?
Shoot the master instance
Shoot
in the
the master in the
head.
head.
You could lose
Yeah,
like
you could
1
lose-
minute of data, for example.
So that is a risky operation that sometimes you have to try, and you would have to account it on your error budget.
But it seems to me like we could run this like A/B testing we have on front end. We could run the 2 systems back in parallel.
Fortunately, no.
It works for stateless systems.
Yeah, so if your system is large enough, it's really impossible to have 2 of a kind of those systems. I'll give an example. If you have 1 million transactions per minute, okay, there's no practical way you can generate that kind of load with the same variety and the same size on a different system. It would cost too much.
They push new features to
Yeah, new features, of course. That's nice for features. But when you're talking about failovers, how do you practice a disaster that takes out your data center without having like 2 data centers or 3 data centers? So, okay, Facebook can try that because they have multiple data centers, but how do we try it? Awesome. How do I practice the failure of the system that controls the data centers? How do I practice
The control system you should be able to unit because you can mock massive data centers fairly easily.
Yes, of course. You can mark everything, but does that reflect reality?
Not entirely.
No, it doesn't, unfortunately.
But how do you make any kind of logic about? I mean, it's like Donald Rumsfeld said. It's an unknown unknown.
Exactly. So you have to make it known.
What will happen if it happens in the middle of the night and you're on call and you wake up?
If it's Shabbos, somebody else will deal with it.
Yes. Yeah, unfortunately, that's not an answer we can give to our clients. So moving on. We need to simulate disasters, and of course, one of the problems is that systems behave very, very differently under stress than they behave normally. Okay? They have very, very different modes of operation when they're under stress. Stress could be excessive load. It could also be, errors, can also be different things. Okay? It's a very different mode of operation, and this is something that's critical to understand. First of all, we need to deal with them differently. Okay? Maybe we want to put them into read-only mode or whatever, maybe do some load shedding and so on. But also we need to understand that some behaviors and some bugs, for example, are only manifest in really, really abnormal conditions. For example, there are some bugs, especially in distributed databases, that you will only see if you have clocks that are unsynced, which is pretty rare. Okay? Or maybe you have some weird network condition, and only then you would see that bug in the code. Okay? This means that some of those issues are almost impossible to test for. And this is one more reason why we have to simulate disasters. Do you know what the faulty fallback syndrome is? No?
Fallback has less testing than your main system.
Not only that. Most fallbacks are not active. They're not actually used. So when you actually use the fallback, it doesn't work. And I'll give you an example. With databases, for example, you have caches. Databases are cached very, very heavily. So when you fall back from the master to the slave slave is cold. The caches are empty. So the performance of the slave is very, very, very low relative to the master. So you fall back to the slave and down goes the system. Yeah, and you DOS yourself, basically.
And another problem that could be if you shift traffic slowly, then you won't see it.
Yeah.
You have to do it.
Exactly. So because of the faulty fallback syndrome, we have to basically operate in very, very different ways. For example, when we fell over from one data center to another, we shift the traffic gradually in order to avoid that. Okay? But this is something that needs to be in your mind when you're thinking about active-passive systems. Okay? Faulty fallback syndrome. Basically, we prefer to have systems that gracefully degrade and don't just break when, when there's an issue, but not always you can do that. The point here is that you can only learn about the behavior of your system under real conditions if you actually observe those conditions in the real world. And you either have to simulate them, hopefully if you can in the lab, but if not, in the real world, or you have to actually see them in the wild, as we say. It's very, very important to improve your processes. We talked about improving our systems, but we also have to talk about the human side of things. Okay? Our systems are not composed only of machines, they're also composed of humans. And we need to understand that our processes also have to be reliable. Common processes are better. Independent processes are better. Contained processes are better, and of course, simple processes are better. What am I talking about? So we have a lot of processes, and a lot of them are manual processes, and some of those processes are common. What do I mean by common? It means that all departments, for example, use the same process. What do you do if you're in a company that has 3 different deploy processes?
3 different which processes?
Deploy processes. Deploy. Okay? That's a problem. Okay? They may be conflicting, they may be impacting one another. It's much more difficult to understand. Okay? Also, what do you have what do you do when that process has 10 different steps? Okay? So you get the point.
Common is a kind of simplicity when...
Common means that everyone uses it.
For instance, it's better to compose a second process out of an existing process and a couple extra steps than retitle a new thing.
Exactly. Exactly. Also, independent processes, it's very important because if an independent process fails, okay, it doesn't impact anything else. Same for contained processes. This has to be in your mind when you're designing the processes in your company. This is not this is not a software problem, okay? But it is related to reliability. Think about the processes that you would have for maybe approving vacation. It doesn't seem like an issue, okay? Until you think about what happens if some manager approved vacations for everyone in the operations team. Then it's suddenly a problem.
I'm on vacation.
Yeah, but is your entire team on vacation?
Okay, I'm on vacation.
Exactly.
Vacation is on Shabbos. God will be
Yeah, you keep repeating that Shabbat thing. I don't understand it. Anyway, you also need to understand that you shouldn't, maybe you want to have different processes for emergencies and for normal operation of the company. You need to think about all of that stuff up front. So it's really important to understand that we have to look at this whole thing holistically. Okay? The system is only as reliable at its weakest part. It's a chain, basically. And this means that we have to look for anything in that chain, anything in the system that might break. And if we invest only in one part of the system too much, then it's useless. It's a waste of money and effort. Okay? You go to a lot of companies, maybe you see a database that's like highly reliable, super duper reliable, whatever, doesn't matter. Maybe they spent millions of dollars on an Oracle system, but everything around it is shitty and breaking. Okay, what is the point? Again, the system is only as reliable as its weakest part. We have to think about this whole thing holistically. So, Let's talk about humans again, the human factor. Humans are the most overlooked part of most software systems. And this is very unfortunate. So I'll give you a few examples of what I mean. Standardization. You would go to a lot of companies, and you would see that maybe the developers are using different tools from the operations people. Maybe different departments of developers are using different tools. This means that knowledge about those tools is not widespread. The ramifications and the corner cases of tools are not widely understood. And often you would have weird interaction between the tools. This is not good. We want some form of standardization. Has anybody heard of the Mars Climate Orbiter satellite?
The which what?
Mars Climate Orbiter. So this is a satellite that NASA have lost because the navigation system and the engine were using different units.
Was it miles, kilometers, and it crashed into Mars?
Yes. It crashed onto Mars because one system was using the metric system and another was using the imperial system.
Well, vote for Donald Trump then.
Yeah, exactly. So this shows you why standardization is really, really important. Also, consolidation. The less tools and the less methods of operations or ways of doing stuff that you have, the easier it's going to be for everyone to manage that and hold that in their heads. Okay? Sometimes maybe you don't want to use the best tool for the job because it means that you have to learn one less tool. Okay? So that's probably better. Redundancy includes people. Everyone knows what the bus factor is?
The what?
Bus factor. Bus factor.
Bass factor?
Yeah. Bus. Like a bus with
Oh, bus factor.
bus factor. Yeah. Okay. Sorry about that.
Hit by bus scenario?
What? Sorry?
They hit by the bus?
Yeah. Basically, so how many people in the company have to be on the same bus?
Thank you.
This is the president and vice president never take the
Yes, exactly. So in order for the company to shut down in case that the bus, has an accident and everyone on that bus dies, okay? So if you have one DBA, for example, and he's the only one with a password for the database, and he's on that bus, you have a problem. Your bus factor is 1.
If your engineers are taking a bus, you have a bigger problem.
That's also true. But if you work for Google in San Francisco, then they have their own bus service. So,
Helicopters are fuck this.
yeah, exactly. So let's call it a helicopter factor, okay?
4 people in that one.
Yeah. Anyway, the point is you need to have redundancy for everything, including people. How many people are doing on-call in your company, for example? If it's only one person, it means they have no backup. If they don't wake up, if they don't get the alert, if they're hammered or whatever, tired, yeah. No one, or maybe it's Shabbos. Yes, no one is going to be able to fix anything. Also, we need to manage fatigue, and wear out and that kind of stuff. If you have one engineer on call, eventually he'll wear out, he'll be too tired, and either he'll quit or he just won't wake up when you need him. And for example, if you have someone that's doing on-call, as a manager, you should probably tell him to go home early because he may be working again tonight in case there's a problem. Okay? A lot of companies, unfortunately, just ignore this and have people on call all the time, and they demand that they work normal hours in addition to their on-call duties. And that's really, really bad. One more thing I want to say about that is try to use the same tools in production as you do in your development environment. If you don't, if you have different tools, chances are when you need to use your production environment to handle disasters, you won't know where things are, you have no idea what's going on, and so on. Same goes for standardization. Think about where the logs are located. In many companies, you ask someone where the logs for the server are, and he's like, yeah, it depends. Am I on development? Am I on staging? Am I in production? Is this service or is it that service? Many systems write to syslogs. Other systems write to log files in var-log. If it's Java service, maybe it writes to a different folder. Maybe the format is different too. Maybe someone forgot to configure logging. We just don't know. Okay? So it's very, very important. I'll give you another example. So has anybody...
That goes under standardized.
What's for it?
That goes under standardized for
Yeah.
all your logs.
Yeah.
I
Give another
like
example. One
call-
second.
I call liking this configuration damn, I black out.
Blacklist. So
That's a fault, we can
Give
test
me,
that.
give me just, I'll be back in a minute.
So did someone... Oh, did someone read...
Convention over configuration,
Yes.
that's the word.
Did someone read the postmortem of GitLab?
yeah.
Yes, because I was drunk.
So GitLab.
And so
The incident in GitLab that took down GitLab for many hours and they lost a lot of data of the clients started because the DBA has erased a folder on the wrong server.
Okay.
he had RimRaf permission in
Yes.
production.
Yeah, it happened.
Someone always does.
2 weeks ago.
Someone always have permissions to erase your database.
And he needs a wife who keeps him away from the computer when he's drunk.
Not the point, he wasn't drunk. He wasn't drunk, he was very much aware. The problem is he erased the folder on the wrong server.
He didn't PWD.
Oh.
I got into an
folder.
argument.
Wait.
I got in an argument with my
One
cousin,
second.
and he hasn't forgiven me yet. We're yelling at him for not PWDing before he brings
It
that.
was the right directory, just on the wrong server. PWD would not have helped.
Who am I?
So now you need to add hostname minus F
Exactly.
to your,
So,
your
the
To
real-
my fetchery.
No, so there really is a solution, which everyone should have implemented years ago, would be just to have on your PS1, on your prompt of your shell, the name of the server. And this is what we do in many places. We just have the name of the server, and we also use color coding. For example, if it's production environment, the prompt should be red. If it's a different environment, the prompt should probably be maybe green or blue or whatever you want.
How do you standardize that across all the different operating systems that people are stupid
Oh,
enough to use?
I'm sure that you have configuration management.
What if you have some asshole who uses Windows?
Let's not talk about Windows because I'm going to scream. Anyway, so to sum this whole part up, some people think I'm exaggerating, that maybe I'm being overly careful and so on. To those people, I say it's not paranoia. People are out to get me. All systems are out to get me, and all people are out to get me. Okay?
Paranoid doesn't mean they're out to.
Exactly. I am paranoid, but people are out to get me. So think about that. A company like Wix, but basically every company that has a public service is under constant attack. We have users. We cannot block users because we want users, but the users are doing really, really, really stupid and weird things that we have never planned for. So we are basically under attack all the time. And I'm not talking about malicious attacks, by the way, which we also have. Because when you have 100 million websites, one of them is going to be DDoSed at every given time. Okay? But think about that. Not only are your users attacking you, you are attacking you. Like, aren't we introducing bugs into production all the time? We are actively breaking our systems on our own. Okay? And if that is not enough, the universe is attacking us. Servers break. Sometimes, lightning hits a data center 5 times. I'm not shitting you. It happened to Google. Okay? This is reality. Okay? So no, it's not paranoia. You have to be prepared for that kind of stuff. Everything that you thought is impossible will eventually happen. This is the reality of life. So let's talk about handling disaster. Meanwhile, in real life, all this theory is really, really nice and beautiful. Usually what happens is something like this. Yeah, it's about 3 a.m. You get some alert from Nagios or whatever. You're probably drunk because you were fixing that stupid server since, I don't know, like noon or whatever. Well, I don't know. Maybe you just put it there before you scramble the floor.
You should maintain the bottom.
And by the way, just interesting question, a philosophical question. Why do things always break at 3 a.m. and not at 3 o'clock at noon? I don't know.
Because
What?
that's midday in the US.
But it also happens the same way in the US. Stuff breaks in the middle of the night in the US. I don't know. Anyway, First thing to do when you have an incident, don't panic. The normal reaction of most people when there's an incident is to panic. And that is really, really bad. It's a very stressful situation, and probably your manager is screaming at you, and they want you to fix things as soon as possible. There's a lot of pressure, a lot of psychological pressure. Really, really important not to panic, to relax. And if you're panicking, don't do anything at all until you're relaxed. That's like the most important tip that I could give you about handling disasters. Second thing that you want to do is you want to have an incident manager. Okay? And by the way, if you're getting a lot of heat from your manager, assigning him as the incident manager is a good way to diffuse that situation, because it will give your manager something important to do, and he will become, your ally, basically. He will become that person whose responsibility it is to take the pressure off. Now, what are the duties of an incident manager? First of all, to take the pressure off, obviously. Second, to watch the clock and the decision lines, because probably the one that's actually handling the incident is going to be too busy to watch the clock. Okay? And he's going to be in that psychological state where he's thinking that he's going to be done in 5 minutes. He's not going to pay attention to time boxing and decision lines. Also, communications. You have to communicate with the clients, let them know that you're making progress. What have you done so far? Where are you in debugging this situation? Are you going to be up soon? And so on. You have to keep other teams apprised. You have to communicate with your managers and so on. This is a very important job, to keep the information flowing. Also, if you have an incident that's big enough and multiple engineers are on this incident, you want someone coordinating and basically distributing information in a way that's not too noisy, but also where all the important information flows. Okay? Very important. Also, maintaining an incident log. So often you would have engineers jump in to help debug the incident or help recovering or whatever, and you don't want to start telling them everything that happens from the first second of the incident. You want to just give them a log and say, read this, all the important information, all the highlights of this incident, and the important points in time, and the stuff that we have already discovered. It's all in the log, just read it. It's also very, very important to have an incident log for postmortems. Because then, during the postmortem, you can go over that log and know, okay, this is what we have done at this point of time. This is the information that we have discovered at, 2:35 a.m., and so on.
Yeah, we usually open a Slack channel.
Exactly. Slack is a very good medium for that. Please don't use Skype or whatever.
No, seriously, I've seen a lot of companies use different chat mediums for incident logs. It's not a very effective way of communicating. Also, it requires an invitation. You want that channel to be open for everyone who wants to jump in. Not necessarily you would want them speaking, because that introduces noise, but you would want everyone to be able to read that stuff at least, okay? Without bugging someone for invitation. Preparing a handoff. So some incidents can take long enough that you would have to have a second shift working on it. And you want someone to prepare the handoff, to make sure that not everyone is awake at the same time handling this issue. You want maybe to send some of your team to sleep so they can relieve the engineers currently working, in 3 or 4 hours. Okay?
What, sorry?
Where is the modafinil?
The what?
It's a medication which is safer than speed.
Well, I'm not talking about pharmaceuticals now. Anyway, the point is someone needs to manage this, and this is a good job for an incident manager. Now, when you are the person handling the issue, never, ever, ever do anything unless you have a solid reason to believe that it will actually do something. Okay? The first reaction that many engineers have when something is broken is to reboot everything. This is a really, really bad idea, and I cannot emphasize how bad of an idea this is. Okay? Why is this such a bad idea? Anyone?
Startup ordering. One example.
Not it, that too, but other
Because
reasons.
You lose your ability to understand what actually happened.
Exactly.
We're
You
not
lose that
Windows.
person, what, sorry?
We're not Windows, resetting is not allowed.
What?
Anyway, so we have lost, if we have rebooted the system, we have lost the priceless information that would allow us to monetize on that incident, on that problem. Okay? And that is worse than anything else we could have done, because it means that this incident will probably repeat itself in the future, and we have not prevented it from happening. We have maybe fixed the symptom, but the problem is still there and we don't understand it. So our priority during an incident, above all other priorities, is to obtain data. Okay? Second problem is that you could actually aggravate the issue. I've seen many issues that would have just gone away in 5 minutes if people just waited, but turned out to be, a shitstorm because someone rebooted the database. And when you reboot the database, this is not going to end in an hour or two. It's going to be, you're going to have a very, very bad time.
The shitstorm, that was some high quality English.
And when someone just automatically reboots stuff, he will probably aggravate the issue severely. Okay? Yeah. So assumptions are the mother of all fuck-ups. Don't assume anything. Don't act without evidence. Always, 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 always look at your metrics, look at your telemetry, and don't do anything unless you have a solid hypothesis that is backed up by data. Sometimes you would want to do some action in order to obtain more data, and that is fine. When you know what kind of data you're trying to obtain, and you know that the operation that you're going to do will possibly obtain that data. Okay? It's okay to do stuff in order to test an hypothesis, but you need to have an hypothesis before you do this. By the way, this is very, very hard psychologically for people because there's so much pressure to do something, anything when there's an incident. I found that for many engineers, especially junior engineers, this is probably the hardest thing for them. Just sit and do nothing unless they actually have an hypothesis. Very, very hard. Anyway, our priority is to collect data. Okay? We need this data for debugging, to understand what happened, but we also need that data in order to simulate the issue, what we call recreating the issue, okay, or reproducing the issue. If you don't have data that shows how this was done, maybe traffic dumps or logs or whatever, we will not be able to understand and to simulate that issue. Also, postmortem. Now, always do one thing at a time. And if you have multiple engineers working on an incident or multiple teams, someone needs to coordinate this. Again, the incident manager, because otherwise you would trip on each other's legs. And also, it's going to be very, very hard to understand the cause of an effect in the system. Okay? Also, you have to be mindful about how much time it takes for an action to manifest in the system. For example, if you are shifting traffic, it may take a few minutes until you actually see this in the metrics. Okay? So when I'm talking about one thing at a time, it actually means a time interval, which depending on what you're doing might be long or short. Communication, super important. We've talked about this a little bit. And of course, after the incident is done, after we finally got the system up and running, we want to have a postmortem to reflect on what happened. And Nathan's going to be talking about that in the next lecture, so I'm not going to say a lot about that. I only want to say one thing about postmortems. If you're looking for a root cause, don't. There is no root cause. When you're talking about complex systems, it's better to talk about contributing factors, not root cause, because root cause implies that there was only one thing that broke your system. And this is not true, unfortunately. Basically, it's a bunch of stuff that combined together in a really weird and wonderful way in order to crash your system. And if you're looking for root cause, you're going to miss a lot of things. Okay? And Nathan is probably going to elaborate on that, so I'm not going to say too much about that. Reliability is a loan shark. Okay? Technical debt, which we all have, has interest. But when we're talking about reliability, the interest is very, very high. Okay? Why? Because issues interact. When you have a bug in the system, eventually it's going to interact with another bug that you have in the system, and you're going to have something that's even harder to debug and very, very problematic. If you have technical debt about reliability measures, maybe you don't have monitoring or you don't have backups, when you will have a problem, your problem will be aggravated tremendously by the fact that you have left such a dangerous technical debt. Again, if we're talking about GitLab, so yes, they had a problem. Okay, that problem would have been a nuance had their backups worked, but they never checked their backups. They had three backup methods, and none of them worked. And what? Sorry? No. They backed up to S3 to cloud storage. The only problem was that the backup has been faulty and wasn't running properly for months, and they didn't check. So maybe some people in the crowd are laughing, and I've seen some people laughing. I don't know when was the last time you recovered from your backups. Maybe you should think about that. That's a very dangerous technical debt. That wasn't the problem. Data wasn't written there. So anyway, you get the point. Ultimately, reliability is about trust. Think about the word reliability, or בעברית, אמינות. If you don't rely on the system, if you're not willing to rely on the system, if you don't trust it, you have no reliability. Okay? And I cannot stress this enough. And to establish trust, we need experience with the system. We need to work with it, for some time, and to actually believe that it works. Now, this goes both ways. If you trust the system too much, it's bad. If you don't trust your system enough, it's also bad. If you trust the system too much, what happens? You make wrong assumptions and complacent. For example, maybe you would store all of your important data on that system because it's like has 5 nines and it's so reliable. So why not put all of our important stuff there? And when it crashes, you have a problem. Also, if the system is very, very reliable, okay, and that's another irony associated with reliability, chances are you've never had experience operating that system in failure. So often you have systems that are running for 20 years consecutively, okay? Think about mainframes, for example, and then they suddenly reboot. What are the chances that they will actually boot properly after 20 years of operation? Almost zero. Okay? Anyway, and of course, the other side of this, a system that you don't trust enough, maybe that system is very reliable, but no one is going to use it. So great, we have a very reliable system that maybe we spent millions on, but no one is going to use it, so yeah, that's great. So yes, psychology is a very important factor when we're talking about reliability. So the last thing I'm going to say in this presentation is that even if you have the best operations team on the planet and the best engineers on the planet, you have to remember that it's not enough. It's not enough. It's a long-term effort, and we have to work on it even when the system is not failing. Reactive approach to reliability doesn't work. So thank you very much. And